All right. Hi. Today I will talk about, server-side rendered micro-frontends. And AWS Lambda is here just like a bonus, let's say, this way. Let me start with some kind of disclaimer. So context is important, and here, fortunately, Google is smart enough to guess that the one who wrote remove child from parent with fork is a poor programmer or someone who is struggling with system processes, not the child murderer. So Google is smart enough to guess the context of the user based on the data. So I don't want you to guess my context, so here it is. My name is Mateusz, and my surname is hard even for Polish people. You can find me somewhere with mat3 login, and here is the link to this presentation. So slides are already online, so you can remember this one link, and all the other links are here for you for the future. So I work for Allegro. This is somehow important for this presentation because I server-side rendered front ends on daily basis there, and I have some Udemy courses also. All right, I really wanted to have a presentation title built out of buzzwords, just like that, just buzzwords, nothing else. But yeah, I'm almost there. This one is problematic. But anyway, this is a nice form because this presentation will be also divided in 3 parts, as this title is divided in 3 lines. So we will start with the server-side rendering. Micro-frontends is the core of this presentation, and as I've said, this AWS is just an extra part. So what is the problem to solve with these fancy buzzwords? The main problem is something you may know from your daily basis, let's say. So let's imagine the company X photographed by Alex Ivy, for instance. And in this company, I think you can relate, they can be multiple teams. So we can have like Rob team. Rob is in love with React. We can have also team of Agnes, Angular lovers, Vitaly with Vue, and for instance, John with JavaScript. And, you know, could be lovely, like me and my boys from the same company, stuff like that. But you know the realities, yeah? So it will be rather like that. So these guys are not going to talk with each other. So we are going to solve it with micro-frontends, hopefully. And in order to understand micro-frontends, we will start, as I've said, with this server-side rendering. It will be a good introduction. Server-side rendering. Each part of this title can be, let's say, adapted separately into your project. So I hope this server-side rendering alone can solve you some problems. And what is the problem? In order to understand what is the problem, we need to understand the history. So originally it was always like we had a server and we had a client, and the server was producing a lot of HTML with PHP or other fancy technology. And yeah, it was like that. We had multi-page applications. Everything was nice, but clients started growing and growing, getting better when it comes to computing power and the possibilities. So it started being an opportunity for all the developers to use this computing power of the client side devices. So then single-page applications trend appeared, and at some point in time, this single-page application started looking like that. So we had one line of Angular put in HTML, and all the stuff happened client-side. So that was problematic. Maybe not for such devices, but we started having smartphones on the market, and still not every smartphone is a powerful device. There are also other guys without smartphones, for instance, and this can be problematic to have too much client-side code, too much content on the page created on the client. So that's the first issue. And the second issue is that sooner or later people will start surfing the net with smartwatches or something like that. So that's the first issue of single page applications. And the second one is search engine optimization. So yeah, as you probably know, there is no better place than the second page of Google to hide something. And what is problematic for these client-side applications is that search engines can have problems with interpreting the content. Google is smart enough to execute JavaScript on the client side, let's say, but simplifying the things, Google has a separate budget for analyzing your JavaScript code. So it can be a delay between publishing your page full of JavaScript and having this page properly indexed with Google. And second of all, not every not every search engine is Google. Yeah, we have also other devices, other engines. So these are the issues with the client-side rendering with a full JavaScript single-page applications. And in order to fix these issues, we should, well, come back to the server. But not coming back, I'm not into coming back to PHP or JSP or whatever you had, because since 2009 we have Node.js, which is also a full, let's say, supported server, which is able to interpret JavaScript. So we can mix our lovely framework of choice, with JavaScript part executed on this server. So how to do so? Let's take React as an example, and SSR is for server-side rendering. So we need a common part, something which will be, let's say, served in both server and client, so like React component. Then we have to start with this component on the server. So the second step is executing a special function for instance, from React. This is not React DOM, but React DOM server, additional part of this package. And it has an exported function like render to string. And then we can use this component, and it will create an initial content like HTML content on the server, and we will be able to send this content to the browser. And within the HTML rendered here, there will be some special attributes which will be then interpreted with React DOM, but not render, but hydrate function. So React will look for the same component. We can provide where the component is, and it will attach to extra attributes rendered from here, and everything should start working. And I have a demo for this. So we can check the example of this code, like having typical component, same as I've shown, nothing fancy. We are checking the random number, and we are going to display it. Then we have this server part. So we are importing DOM server. Then we are rendering this and putting it somewhere in the HTML. Then the client part will do just hydration. So this is what I have here, and I can refresh it, hopefully. Yeah, everything works. So we can check the console now. And in the console, there is an error because what came from the server was first random number, and then React started to hydrating this part, and there was a difference. So it is just warning us that there is something different between our React code, server code, and client code. But this is intentional here. So in view page source, we can check what really came from the server. And as you can see, this is the HTML with additional React attributes, yeah, for server side, from server, for hydrating what was server side rendered. So this is simple, and this is all of this is nice. But we have a separate API for Vue rendering, for Angular. All these modern frameworks allow us to server side render, and it is hard to remember all the APIs, so it would be nice to have some kind of an abstraction level, additional instance entity, something which is able to abstract this logic for us. And we fortunately have. I found a tool called Hypernova, and I want to show it today. And the flow is similar as we had. So we have our browser, we have our Express application, which serves HTML with additional attributes, and we have additional Node.js instance, which is responsible, which has this Hypernova running, and it can be treated like a library of all the components we want to server-side render. And Hypernova provides a nice API. So no matter what the framework is, you can write even your own adapters, and you need to expose just two functions. First for client-side rendering and second for the server-side rendering. And the flow is as follows. So we are, from our browser, we are executing get request, and then this express should execute post request for the special endpoint, which is batch. And within the request body, we are sending all the components by their names we want to server-side render. And within the body, we are also sending initial parameters, properties for the components. Then the server responds. All the components are, let's say, rendered within with this server abstraction API, and then everything is returned. Also, the browser is taking from the Hypernova the client part for hydrating. Yeah, so we are starting with the initial load from the server, and then we are hydrating like that. So I have also an example for that, and as you can see in a second, it will abstract for us a lot, because I don't care how server-side rendering in React looks like. I'm just executing render React method from Hypernova React, and what's more, on the client side, I do the same. Yeah, so this is really nice. There is a maintainer for this Hypernova React, so I can just rely on their implementation. So this is like from Airbnb, this tool, Airbed and Breakfast. So they introduced both Hypernova and Hypernova React, and the only difference from the previous example is that I'm providing here additional property just to show you how to parameterize. So the server part now, it looks similar, but we are referring to the script, so the client part from Hypernova, and we are not rendering anything here. We are calling renderer render, which is Hypernova client, also from Airbnb, and we are providing our body, which is, as I've said, the component name and all the properties we want to initially render with. So this is the code, and let's take a look at the example, which is probably here. And yeah, we got siemanko instead of hello. So that's the difference, and we can check the page source, not the selection source, but the page. And as you can see, now we got not only React attributes, which are somewhere here, but also additionally Hypernova attributes. So everything was initially rendered on the Hypernova server, then it was passed to the Express server, and we got the response, hydrated it, and we get an interactive page like that. So this is nice. This Hypernova is worth remembering because it will help us a lot with these micro-frontends. So, time for micro-frontends. Originally, in the history of software development, we had a team of developers, brave developers who were responsible for the whole application, from the database to front-end and so on and so forth. PHP application or something, you know the stuff. But then, after some time, people started to specialize and started dividing the code between front-end and back-end. So we are front-end developers, probably there are some back-end developers, and so on and so forth. But recently, maybe 5 years or something, people started dividing this back-end part even further. So we have now microservices. People started thinking that it is better to have specialized teams responsible for like a business value. Here we can use our document database, here relational one, and this division was pretty good. But yeah, about microservices, this is probably the summary. And yeah, there were plenty of talks on the topic, so I just want to sum it up briefly. So there are some bullet points. So we should divide our application using nice business, let's say, boundaries. We can rely on the self-containing, so our services should be independent from each other. We should, for instance, cache a value from the one service if we really need to. We should not rely on the direct communication totally. There is a technique called bounded context, which helps dividing the application into microservices. It comes from domain-driven design and so on and so forth. So that's the first, let's say, bullet point. Second is that all the microservices should be deployed independently. So no matter what the speed of your team is, you should not wait for other teams. You should just deploy. Then there is a possibility to divide. As I've said, you can choose the perfect database for you. You can choose the perfect programming language for your problem, and so on and so forth. And these were rather the positive things. And the thing which sometimes is missing on the slides in the presentation is that we should have some kind of the responsibility. So there is a realistic approach is that one microservice is owned just by one team. There should not be like microservice which is handled by multiple teams. Like team can have multiple microservices, but not the opposite. Yeah. So that's the important thing which sometimes was missing. And yeah, it leads to a problem, but let me hydrate myself. And here the problem is, so we have specialized teams separated using independent deployments and technologies and stuff. And at the end of the day, they need to synchronize their code in this part. So this is problematic. So that's why micro-frontends came into play and people started dividing not only the backend part, but the frontend part as well. And regarding micro-frontends, there is a nice web page called, like that, microfrontends.org. And here are the bullet points, which are like the extension of the bullet points shown previously. So we should be technology agnostic. So if one team rely on React, it does not matter. The second team should rely on whatever they want. So the second bullet point is the team code should be isolated. So we should not spoil the window object. So don't put global variables and stuff like that. We should be really isolated. Then if we are not isolated enough, we should also have, at least we should have the differentiator. So our team use this prefix. Remember about that. Yeah. The other bullet point from this web page is that we should rely rather on the native events API, for instance. We should not reinvent the wheel and create our own PubSub or something like that. Yeah, we should rely as much on the common, well-known mechanism established ones as we can. And last but not least, our web page should work in the universal way. So it's not like we should have full JavaScript code, because we already have seen that it is not the perfect approach. We should rely here. This point is extended within the articles presented here. It is described like we should have server-side rendering, period. So how to approach these micro frontends? The bullet points were as followed, and now the concrete dividing and techniques. So each team should have their own components. Yeah, team is responsible for the microservice or a couple of microservices. It should be also responsible for a couple of components, and then we should synchronize those components. That's the stuff, let's say. Synchronizing client side is possible. As I've said, it's not the recommended way, but it is doable. We can use iframes. We can use the framework called single SPA, where SPA is single page application. So the name is single page application. Yeah, but it is like that. We can use it, and we can also use web components, which is a native browser mechanism for creating your own, let's say, JavaScript and HTML parts working, cooperating together. From Angular, from Vue, we can easily create a web component out of Angular API. So the Angular component can be compiled to the web component. We can easily consume web components within all the frameworks. React has some problems with creating, let's say, web components out of their components, but it is also possible to use web components in the React app as well. Yeah, so these are client-side techniques for synchronizing separate components. Then there are server-side. So ESI from Varnish, for instance, this is one technique. Server-side includes another one, and the third, which will be shown later in a minute, is Hypernova. And the last possibility is to use some kind of private NPM and synchronize all the code during the build time. But yeah, I think the most convenient way is to use Hypernova. So let's see the demo. Let's start with a demo for the more ambitious, let's say, example or on server-side rendering React app. So this is here. I wanted to create something using yet another buzzword. So it appeared there is a GraphQL endpoint. Let me check it. GraphQL API for taking the data about Rick and Morty TV series. Yeah, so there is a public endpoint like rickandmortyapi.com/GraphQL, and you can use it easily. So yet another buzzword here. So I wanted to have this React component consuming GraphQL, server-side rendered, and put in the browser and hydrated. So it is super easy to do so. I've just created my own implementation of render React, which is called render React with Apollo, and the API is super simple. It also contains this server part and the client part. So this is very easy. You can go for Apollo client and read on their web page how to server-side render, and it is possible. So I've just copied it here, and it appeared to work. And yeah, so we have our own implementation of server-side rendering, and we can use it on Hypernova, and then we can use it back on our server part and client part as well. So let's see it in action. As soon as application will start to work, we should get the list of all the Rick and Morty characters, let's say this way. So let's check after refreshing this web page. Here is just server-side rendering. So we got all the data immediately, no loading or something like that. Let's check the page source. The content loaded now is much bigger, yeah? So our server part of the application did a little more than previously. So we got all the data from the GraphQL query response. We got it rendered here. So this is just a React app. And now let's mix React with Vue. So let's have a real micro-frontends. So in order to do so, I've created same component as previously. So we have this React component for getting all the data for Rick and Morty, and we have also a Vue component here. And the Vue component is a simple form with a search input element, and right after submitting, we are communicating with native browser's API, as it was promised. We should rely on the native APIs. I'm also using a prefix, so search is a one team responsible for the search engine, for instance, or something, and this is the event which is published from the Vue component right after submitting the form. Then we have the React component, which does this querying of GraphQL endpoint, but it also, here, it listens for the event published somewhere in the document. And right after the event occurs, we are executing the search change listener. So what we are doing from Apollo GraphQL client, we are taking all the stuff, which one of the data is refetch method, so we can easily execute GraphQL query once again on the client side, and we are basing here on what was published from view. So our event from view was search changed with detail, and the content of the detail was what was typed inside our form. So now our Hypernova server is a little more ambitious, let's say. We are having two components, first for rendering this React part and the second for rendering this Vue part. So this is also a package available on NPM. You can easily plug to our application. So let's check it in action. Let me refresh this page. And yeah, so I'm getting here two components. First is this search, and second is this React tiles. And I can easily type here, for instance, Rick, and right after submitting the event, all the things here will be client-side re-rendered. So let's execute it. As you could see, there was loading for a second, and everything was got successfully. We can also provide some strange name, like something which does not exist in the Rick and Morty universe, so we are getting the third state, and everything here, as you can see, works. So, summing up, we are using this Hypernova to server-side render our components and then hydrate them on the browser. And this is something which can solve our sad folks names. So using these techniques, we can easily synchronize, we can easily cooperate with each other. And last part of the presentation, as I've said, the extra part is about server-side rendering everything, but not using ordinary Node.js, but serverless computing, AWS Lambda. What is AWS? Let's start from this. Well, yeah. I work for Allegro, and Amazon is a small copy of Allegro, let's say this way. They are also in the e-commerce sector, and e-commerce is problematic from some perspective. So ordinary day is like we have like, I don't know, X people browsing our web page, so the activity is at the level of 1, let's say this way. And suddenly, out of nowhere, there is Black Friday or Christmas or something, and we are having a peak, like 5x, 5 times more people started buying. And this is a problem for e-commerce, and Amazon had this problem as well. And they had to buy an infrastructure for handling the user's activity at the level 5x. But at the ordinary day, 80% of this infrastructure was not used. So they've started just renting their hardware, and they've introduced a couple of APIs around this renting stuff, and this is like that. The first public cloud provider appeared. So this is Amazon, and Amazon AWS Lambda is one of the services, additional service, because the first one, this renting infrastructure, was just virtual machines in the cloud, so EC2, and now we got AWS Lambda. But as we've seen, the names are confusing a bit. So AWS, we have a special web page which translates AWS English into plain English. So our Lambda should be called AppScripts, and it is nothing more than the storage for our functions. We can store for free, but right after the function is executed, we are paying for it. What is interesting, the first million of executions of our simple function is free. First million each month. And we can write our functions in JavaScript, Java or Python, no matter what. But here's the secret. It is called somehow by some people serverless computing or function as a service, but here's the secret. There are servers behind the scenes. So this JavaScript function eventually is going to be executed on some kind of Node.js server. And moreover, right after AWS started having this public cloud, other players, let's say, appeared. So we are not only having AWS Lambdas, but we also have Microsoft Azure functions, Google Cloud functions, and so on and so forth. And every single service from here has its own APIs, its own, let's say, problematic things. So as in some point in time we had jQuery, which were, let's say, a common ground for all the browsers. Now we have serverless framework, which is a cooperative, let's say, API, which can be translated to whatever cloud we want. So I strongly recommend starting this serverless computing with this framework. And in order to go with our micro-frontends on this framework, we have to use just a special implementation of our Hypernova and our server. So the API in this serverless is similar to the Amazon Lambda function. So we need to export something, and it takes 3 arguments, and this callback has to be executed somehow, but we easily just pass all the arguments through Hypernova function, which is coming from Hypernova Lambda implementation from NPM. And the rest looks similar to what we have already seen, and the server part is even more similar, let's say, to what we have seen. What is nice about this serverless framework is that it can easily configure everything for us. We need to go with a serverless YAML file, and we can provide, for instance, for the server, I'm having this exported function, which is home here, and I'm pointing to this home within the serverless YAML, and I'm exposing it on the get method to our serverless. And what I'm also having here is that I'm going to deploy it to AWS with Node.js 12, and for the local development, I can use serverless offline. So as we have here this Lambda, Microsoft Azure, and Google Cloud, we can also plug a 4th, let's say, implementation like serverless offline for the local development. And I've also created a Lambda for this Hypernova here, and as I've promised, this Hypernova is from Hypernova Lambda implementation, and the configuration is even is similar. Yeah, we have this batch method exposed on the batch endpoint with a post HTTP method. So, well, the application works the same, but behind the scenes, well, yeah, we got the problem, network problem, probably I lost the connection, but nevertheless, the implementation is as the previously. So I'm not deploying for now to real AWS, but I'm using this serverless offline, and normally it works, let's say this way. So, in order to learn more about all these things, I recommend the articles written by this guy. This is the article which extends this concept of this serverless Hypernova server-side rendering, because, yeah, this guy is also the author of Hypernova View and Hypernova Lambda, so he wrote a lot of articles on the topic, and that's basically it when it comes to the concept. So, 10 seconds more for a comic strip. And if you liked my style, you can you can subscribe to my newsletter. For the Polish version, it's trendy, not trends. I also run workshop in 2 weeks. This is the link to this presentation. This is the GitHub repository with all the code examples I was showing, so you can also come back to it. And that's all I've prepared for you today. Thank you for your attention.
Questions, please. Piotr, you were first again.
So my question is mostly for the combination of micro-frontends and server-side rendering. So one issue I have with the idea of micro-frontends is that, of course, I agree with the separate teams should handle separate things, and if they intermingle, then all the bad stuff happens. But then, if they choose to use all of the different tools, so one uses Angular, one uses Vue, the other one uses their custom built framework on vanilla.js and bugs, right? And then it all gets combined, thrown into a single page. Of course, we can do server-side rendering on it, but then once the user loads it on their low-end smartphone or their new smartwatch, all of the frameworks have to load, and even if we offload them, how do you mitigate all of those performance problems?
Yeah. So the problem then appeared, as you pointed out. So in the critical path, you should not mix so many frontends. So it is also a matter of dividing your team's responsibilities in a proper way. So for instance, well, I don't know how much I can say about the Allegro approach, but in the critical path, you should minimize the frameworks, and for the other parts, you can put teams together. Like this team works on React 17, so you are loading just one version of React on the sub page, and then it works. There are also examples on this micro-frontends.org and in the article linked somewhere in the previous slides, which do nothing but just server side. So there is no hydration later on. So there is no interactivity on the page, but right after clicking on the link on the page, you are just getting another web page. And it can be handled this way if you really have to support or your most, let's say, critical users are using low end smartphones. So I believe this is described somewhere here within the links, not maybe here, but yeah, either micro-frontends.org or somewhere else. I've linked to the article of Martin Flower from Martin Flower webpage, and the example provided there is using just this server-side rendering. So it is possible to turn off JavaScript in the browser and just go with server-side rendering all the time, yeah, and this is the approach I would say could work for the critical users of you using low-end devices.
Nice. And one last question.
I would like to ask a question. Maybe because I'm a bit old-fashioned, but why you don't use jQuery? According to the fourth of bullet points, we can see here, jQuery already use the cross-browser approach. And what is the main reason you use serverless framework instead of jQuery?
No, yeah, okay. So I was referring to jQuery here within this slide, I believe, because jQuery was a common place to make a common API for all the browsers, yeah. And here I'm not having a browsers, I'm having Node.js instances, yeah. But here it is hidden behind AWS Lambda. Here it is hidden behind Microsoft Azure functions. Here behind Google Cloud functions. So jQuery was for browser, yeah, all the browsers mechanism, and here is for Node.js mechanism, especially the ones connected with the function as a service approach from all the providers. So that was the
and to make it clear, we don't have jQuery for Node.js, right?
I don't know anyone who would use.
Piotr speaks. It's called Cheerio.
Okay. Well.
So thank you. Okay, one last question. Okay.
Hi, that was nice talk. I want to ask about this example where you had a search in Vue.js and tiles with React.
Here, as well. Okay. Without serverless.
What if, for example, if this is managed by two separate teams, and I just wanted to deploy only the tiles part? Can I do it with Hypernova?
Yeah, because as you can see here on the server, you declare. Here I have simple examples. Yeah, so I just had one root like / and I was getting two components here, yeah? So whatever you have here in the payload, you can send to Hypernova, and it will return just one component or all the components you listed here. So you can list, in case having 50, you can list just 40 or whatever number you want, yeah?
Okay, but what if, for example, the tiles API have breaking changes with other props? How you can manage it? You need to deploy all the whole Hypernova instance, yeah, in this case?
Yeah. So then you have to support all the versions on the Hypernova server. Also, you can adapt some, migration mechanisms, like there is a default parameter or something like that. I'm having probably a default parameter here. So it works also with defaults.
Yeah, okay, cool. Thanks.
Thank you very much, and applause for Mateusz.
Thanks.